Hey there, welcome to the Introducing Project-Based Learning lecture, the first lecture in the Innovation by Design Project-Based Learning workshop series produced by Iowa State University's Center for Excellence in Learning and Teaching. My name is R.Whitehead. I'll be taking you through a few different lectures on this topic. We'll try to break this down to see what you need to know about either course design, course activities, assessment, ways of either converting existing classes into PBL classes, or starting your brand new PBL class, even if it's something that you've been involved with project-based learning and you just need to touch up on some of the tactics, we can help you with that as well. As we begin with the first workshop on this, introducing project-based learning, we're going to talk about some of the philosophies in learning science, some of the features of project-based learning courses, the formats, different objectives that you could use. Before we just dig into that information, we want to use one of the tactics that we normally would use in project-based learning, which has to do with trying to engage the learner right away in a means of sort of self-assessment and questioning of what it is that you want to learn and how you want to go about learning it. With this, I'd ask you, what are your interests or questions about project-based learning? What do you want to know about by the time we're done with this? What sort of things will you take notes about? How will you then try to assess whether what you've learned is sticking or how you have other additional questions? By way of introducing who I am, I'm an architect. I'm an instructor in the Department of Architecture, and I have been for 12 years. I teach design studio and architecture. I teach architectural structures. I teach design build. My research interests are in the scholarship of teaching and learning. And as a faculty fellow for high impact practices at the Center for Excellence in Learning and Teaching at Iowa State, I've been trying to understand different ways that haptic learning methods and even project-based learning methods could be applied to broader things besides just design topics. What you're looking at here is a research question that I developed when I came from practice to start to teach. The practice approach to building structures is quite different than the academic approach, and I was curious why that was. In practice, there's a lot of hands-on work and a lot of models and interactions with structural engineers, where in school mostly just formulas. So I was curious why that was and set out to try to figure out what topics or what ways of presenting architectural structures might make the learning in fact more effective. So my research question was how to examine the learning benefits of integrating haptic engagements and visual simulation tactics in a project-based learning approach for an architectural structures course sequence. This research question led me to the complete redesign of 5 different structure courses, helped me write 2 different textbooks, including one of them that you see here, and the work is recognized with awards from the Building Technology Educators Society and the Association for Collegiate Schools of Architecture. I bring this up because the important part about this was the project-based learning approach allowed me to be able to take what was normally a science course and to be able to think about different creative ways that students could look in and interrogate their learning. So here's the classic way that a course will begin, right? We show an expectation of course objectives that you'll learn when this is all done. And although this is obviously important information, and I hope you do take the time to read these objectives, right now, I wanted to point out that you're probably thinking to yourself that you're getting ready to be walked through a step-by-step process of accumulated knowledge. Like I'm just going to talk about objective 1, and then 2, then 3, then 4, and you'll be expected to understand 1, 2, and 3 by the time we get to 4. So your brains are already set up for a passive learning method. So, especially because you're watching this online, it makes that even worse. I really don't want to do that. In fact, I want to do my best to try to figure out different methods for you so that we can make this process a little more active. So I'm going to start by using some of the fundamental features of how a course could start, using some of the tactics in project-based learning. By showing this to you, then hopefully we can see better how it might work. I'm going to use a few different tactics. One of them is backwards design. The second is called inductive learning, which is where you would learn by example and observation. And the third is the case study method. So with that, I'm going to start and showing you one of the projects I worked on with architecture graduate students several years ago. Let's start by what its course objective was. How can we design and build a shelter for a community partner in 8 weeks. That's relatively straightforward. We had budgets, we had materials, we had a time constraint that was on it. We actually had to teach them lots of skills about both designing and constructing, project management. Had to go relatively rapidly. Not a great deal of creative endeavors in it because we were trying to make more conclusions. So it wasn't very open-ended as one might expect. Part of this has to do with defining that question in the way that I did. Design and build a shelter for a partner in 8 weeks. Here's another approach to project-based learning that takes a quite different tact in terms of the question and expectations for what needed to be produced. So again, as you're looking at this as an example then for either a case study method or inductive learning, what I wanted to point out with this has to do with both the question that led to this and the skills that were expected of the student. Let's start with the question. The guiding question for this 1-week project, which is a very small length of time for a project in architecture school, was what are the spatial and material qualities for a space that promotes mindful living? So the student was then asked to do research about what these terms meant and to try to translate those into a physical space. As you're looking at this and as you're trying to translate this into courses that you design and create, ask yourself, what level of learning is evident in this artifact that was produced? What process then led the student to this artifact? The student by this representation is translating the base level of knowledge about architecture. There's the sun, there's material, there's a directionality to all this, there's a proportion of space. There's an application of this knowledge then too, where this isn't a conventional space and it's not even drawn in a conventional manner. Synthesis, the other thing that's evident in here, is that several different topics are all brought together to create this intended experience. And evaluation. The student was able to present this work, to talk about this work, revise the work as needed, and finally to produce this. All of those things, knowledge, application, synthesis, and evaluation, are examples of higher order thinking at the top of Bloom's taxonomy. A few other examples for you. This is a 10-week process for a large studio class of interdisciplinary students. This design proposal, which I'll go through quite quickly here, just to show you that there's a synthesis of research and discovery and empathy. They were looking at disaster relief tents. Specifically, they were looking at the deficit of how these all sit on the ground and disease and damage and things happen from there. So their first several weeks were spent doing the research, doing the discovery, finding empathy. So all great project design courses first need to be able to take them out of their original mindset into a new mindset. Have them do research. Have them think about joining an existing conversation. The second phase of this work is the application of knowledge. How do you put the elements together? These students met this by learning about structural materials, how they'd be fabricated. They also then employed different graphic skills and physical representation techniques. The point here isn't to look at exactly what it is they made. What I want you to consider is that there's a diversity of different ways that knowledge is applied, and that these different ways that the knowledge is applied are directly in line with the larger learning objectives for the course. Finally, the ultimate goal of any project-based learning course is the presentation of ideas. So they've collaborated, they've presented this evidence, and now they defend their learning. So what they did was they took their full-scale prototype, they built it, assembled it together as you can see here, even stood on it, and took questions for about 45 minutes from a series of professional experts. So simply put, what does project-based learning get you? It takes you from this idea of discovery. It takes you through the process of development. In this public presentation of ideas, it means that the learning is theirs forever. They also applied for a patent, which is one of those things that happens in project-based learning where the project can take on a life of its own outside of your course. This was another example from the same interdisciplinary course in which these students used more science, but it was really hands-on. They found themselves wanting to make a new type of brick to help houses in Mexico be more resistant to earthquakes. So their process was trying to understand how forces worked. They then did different experiments, set up their own parameters themselves, coordinated with structural design experts, and even developed some new tools so that they could try to figure out resistance of whether this would work or not. I show both of these projects because these happen in the same studio. And yet, because there's a flexibility in the project-based learning, the students were able to define the expectations of what they could make and what they could do based on their own research, based on their own way of defining it and embracing that knowledge. Last example from the same studio has to do with a multifunctional water station. These students then worked with an existing problem. One of the components that we'll find with project-based learning is that the problem needs to be authentic. So to authenticate their project, they worked with the Engineers Without Borders student group at Iowa State, found that they had already designed a well for Ulna, Ghana, this village in Ghana, and they set about trying to figure out what they would have done if they would have coordinated with this group sooner. In that, they worked on their design and purpose, used a whole different set of skills about how things would be constructed, and then eventually tested their work. This is really important work because it was authentic and real world, and it challenged curricularly so much as what was wrong in architecture. It was something that they wanted to do themselves, and it took the course in a particular direction in which all of their activities led them to doing things that really didn't happen quite frankly in many architecture design courses. Why is that important? Because as an instructor, and those of you that are listening to this, I need you to know that your task here is not to direct every activity for the students, not to know what all the answers are going to be. Your job is to provide a framework that these experiments can happen. Your job is to have a certain amount of flexibility to encourage these experiments to happen. To say, yes, I see the authenticity of your work. I see the challenge that you're trying to create here. Let me encourage you to do so. By showing you those examples of the previous projects, I was able to use a tactic called backwards design, inductive learning, where hopefully you've learned something by example and observation, and the case study method. Now I'm going to use another tactic for the next few slides called coached ideation to explain the benefit of backwards design, or in other words, it's called backwards mapping. This is essential for project-based learning because it provides a planning framework that works back from the module's overall objectives, and it creates a series of lessons that you're able to build up to help achieve these goals. With backwards design, you start with the end in mind. Backwards design is a planning strategy that allows for a goal-focused approach with distinct phases. So this is going to allow you to align your short-term activities with your long-term goals. Content production and student performance are all able to be linked together. This provides you with the scaffolding, the framework for your course. Progress in project-based learning courses may not happen linearly with predictable results. It's in fact quite open-ended, as you saw from the previous examples. But it doesn't mean the instructors can't provide a framework for this advancement to happen. In fact, it's essential that you do so. You can be flexible in your tactics, but you have to be able to have a strong framework in which those things occur. So you'll be in charge of setting up lessons and problems and goal-oriented assignments. Students can work towards these deadlines and then craft the process of teaching to support these goals. If you're interested in creating a project-based learning course for yourself, consider the final presentation of what your research or project course might be. What manner of artifacts or evidence would be ideally produced at the end of this process? And why? But it varies from major to major. I'm not asking about what is normally produced in these courses, but what you think is ideally produced. This is a way that project-based learning can break out of the boxes that's normally constrained by some curricula. So think then about the learning objectives, course outcomes, even for most of you, professional practice standards, or curricular requirements. But then spend time with this question. Think creatively about it. If you could, if you could just imagine what would be the best outcome, what would be the best evidence, what's the best artifact, think about that and keep that in mind before we start working backwards. This is another important distinction before we move on. You realize I haven't actually taught you anything about project-based learning at this point, and yet I'm asking you to situate your experiences and learning based simply on what you've seen and heard. I'm asking you to think about what project-based learning might mean to you. So this method then is the coached ideation method. Instead of asking you to wait to get knowledge, to try to apply the knowledge, you can then use your experiences and situate your experiences to then have some ideas about what it might be when you're done. So what are the qualities of effective project-based education? Honestly, in one slide, it's important sometimes to be able to present good ideas and bad ideas. So no, education is not something that had to be put into children. That's a teacher-centric approach. Right? The project-based approach here is where you're thinking about igniting things, training the mind to think, learning by doing. See some incredible thinkers over here on the right. So how do we then achieve the yes? How do we engage the mind in the learning? So what we have to do is, of course, contextualize these goals within the setting in which this learning occurs. And this, I think, is the big thing to consider as you proceed with your project-based learning and your course design. One-way communication and passive learning, which is an essential part of a balance, is, I should mention, an essential part of a balanced education. I lecture, just there's tactics to be able to lecture in which you can make it so it's a little bit more interactive. So, in the early 1990s, educators increasingly realized that most students were not really motivated to learn science through this method, and that even the best students only acquired superficial understanding of science when it was a one-way communication in settings like this. John Dewey in 1959, whose laboratory school at the University of Chicago was based on this process of inquiry. So Dewey argued that students will develop personal investment in the material if they engage in real, meaningful tasks and problems that emulate what experts do in real-world situations. So look at some of the conclusions then. Undergraduate students are more likely to fail. Active learning methods, which of course can happen in these particular classroom settings. Flipped classrooms, discussions, clickers, 20-minute modules, all can improve this. Dewey, of course, as I said, went one step further, which was he said that the actual activities have to be more than just listening. Students have to engage in real, meaningful tasks and problems that emulate what experts do in real-world situations. You may be saying, so it's a hands-on learning method, right? And the thing is, it might be. So labs may be better for learning because they're hands-on. But what are the limitations of labs? If you actually think through what learning happens in labs, you learn to be critical of that aspect as well. The basis for project-based learning started in the medical profession, in a practice setting, in which students would develop inquiries and discuss a hypothesis around a problem. The problem, of course, being either someone's illness, how to diagnose the illness. In that, they were taught a collaborative sort of back and forth interrogating process of problem solving. Resolution in this thing was the key. It wasn't about open-ended exploration. So the thing is about lab work is that the scientific process actually likes resolution and definitive results. So think about the labs that you've either taught or participated in. They often are designed to create a particular result. So yes, learning is improved in the labs because there's a hands-on process that you learn more maybe about the tools themselves. There's haptic learning engagement with it. You can actually see how things happen. But labs have usually a solution that's intended at the end. So when you focus on that, it's sometimes called what's referred to here as a cookbook procedure. So the learning is diminished if all of this, you're just sort of following steps 1 through 10. Even the assessment of the labs can happen at a superficial level if all you're focused on, say, is the technical vocabulary or even your ability to follow instructions. Think about instead how you can consider prior knowledge or provide coherent explanations of real-world phenomena that maybe isn't possible to simulate there in the lab. Give students an opportunity to develop their own explanations of the phenomena instead of saying there's only one right answer to it. So what if the problem with learning wasn't the setting of the class, but in fact the nature of the inquiries and the knowledge acquisition process? I want you to consider the traditional teacher-centered approach to knowledge acquisition. Course design oftentimes is set up in different modules of teach, apply, and assess. We're taught that to build up knowledge of one topic within the broader curriculum or practice. And then we have teach, apply, assess, next module. Teach, apply, assess, next module. So in doing so, we're intending to bring up broader skills. But the problem here is that when we think of it as that only, that there's a problem and therefore there's a solution, we forget about this middle part where learning occurs. Learning is the process. So some problems have this direct task approach. So in the direct task approach, oftentimes this is very useful. There are some things we absolutely need to teach in terms of skills and knowledge. Knowledge and comprehension and application. We have to be able to say, for instance, how to size a beam for a building. Now this means that there are right and wrong answers to it. So essential aspects in all courses. Problem-based approach is another way of thinking about this in which it's a real-life problem that maybe needs solutions. Solutions that can be developed and tested. So in this, for example, what if the problem was food safety and security? What if the problem here was how can we introduce this particular genetic strain of crops to a new region? In this, I wanted to point out one thing before we dive too deep into this. If you'll notice, this is called problem-based learning, not project. The problem is still a problem. This problem then is defined by the teacher. There's no problem in doing this at all. It could be essential knowledge that you're trying to learn by giving this problem. These problems are designed to test how students can apply the knowledge. So in this one, it's not usually a straightforward right or wrong solution. There are realms of answers that are right and wrong, and it's a useful exercise. Of course, the harder the problem that you give, the trickier the process of how students get to these different solutions. They have knowledge, there's some skill development, maybe they're working collaboratively here. So when we work towards synthesis and evaluations, which is the expectation of being able to come up with these solutions, various solutions happen. So perhaps the second group may come to a conclusion that the new strain of crops is the right approach for the problem, or maybe it's not. Or what if the group comes up from this process with a traditional perspective, and then the third group gets pretty uncomfortable because they don't think that these crops should be used at all. What do we do then when we have different solutions that might all be correct? So project-based learning, and even what's called the design thinking method, is intentionally an open-ended process. It's an ideal teaching format for inquisitive learners and complex problems. I want you to consider when we look at this if we're still within the same realm as food safety and security. Imagine how difficult it would be to teach a course in a traditional manner in which we ask questions like, why isn't food safe? What makes food secure? Who's hungry and why? So my rule for you is to trust this creative process. In project-based learning courses, students can embrace the multiplicity of considerations found in these questions with your help and your framework and your guidance. Setting all that up, you find that they can help discover, and develop, and test, and even present their work through various stages of activity. You're helping them learn through doing.